Hi dear student friends. So I will be in continuation with the previous sessions. I will be taking you on functions, arrays and strings. So I am Mr. Manjunath, working as an assistant professor in the department of CSE, Reva Institute of Technology and Management, Yelahanka, Bangalore. So in the previous session, if you look at certain concepts what we have discussed in the previous section, so we have seen like the situations where arrays is must to make the programming easier. So we have seen like when we need to have when we have to program on a list of elements of a similar type, say a marks of a students, or it can be like the names of an employees, so of an organization, or the a list of a temperature of an year, something like that. So we need to make use of the arrays, otherwise the programming becomes more difficult. The next we have seen, so what are the basically arrays? We have defined the arrays as it is a homogeneous collection of elements stored in a continuous memory area. Homogeneous means we have seen like, so there should be a similar data elements collection it is. So it is like if I take int a of 10, then it is a is an array of 10 integer elements, and if it is like a float x of 5, then x is an array of so 5 floating point elements and so on. So then we have seen the declaring of an array. The C programming language supports the construct, so which is exclusively meant for the declaration of the arrays. We have seen that particular the syntax of declaring an array, and later we have seen even the initializing of an array and then referring to an individual element of an array, and we have seen a simple program on array. So I take you on this particular continuation with the concept of arrays in this session also. The objective of this session is like after the end of this particular session, you will be able to answer so certain like what is the caution or the measures we are supposed to take when we are using the arrays, and we will see few more simple programs on arrays which you can able to write, and then we will see so how to read the values to an array elements from the keyboard, and also we will see a program of finding the maximum element in an array of integers, and also a program of finding the minimum element in an array of integers, and also we will look into the one of the major problem like the searching problem. So that is in a list of elements how to search for a particular key element. So we will see all that in this particular session. Now, so with respect to the caution while using an array, whenever we are using an array, so we should see to it that whenever we access the array element, you should not go so beyond the boundary. So that is, so whether the index points to an element within the array or outside the array boundary, you must be very careful when you are declaring it. Say, for example, so if I am going to declare an array as int a of 5. So this is an array of so 5 integer elements, and here the index starts from a of 0 and it will go up to a of 4. So here the lower index is 0 and the higher index is 4. So always the array index starts from 0 and ends up to n minus 1. So here if we try to access a of 5, so we cannot access the element, because this is, we have seen that so each particular integer takes 2 bytes of memory area. So here a of 0 will take 2 bytes, a of 1 will take 2 bytes, a of 2 also will take 2 bytes, a of 3 also will take 2 bytes, a of 4 also will take 2 bytes. Altogether we have 5 elements here. So 5 into 2, the 10 bytes of memory will be allocated, and if I try to access a of 5, there is no space wherein the element has been so given the space for allocating the data over there. So memory is not allocated, so it is not so a rule that we should not access the array elements outside the boundary. The boundary for this particular array declaration a of 5 so is the lower index is 0 and the higher index is 4. So that is so when result of accessing an array outside its boundary, if you try to access an array element outside the boundary, so the possible kind of errors or the consequences what we can see is so the likely to corrupt the data. So when we try to access the array elements outside the boundary, so here so in this particular case, if I try to access something like a of minus 1, so or something like a of 5 or a of 6, in these particular situations I am not within the boundary of the array. So here the array is the boundary is 5, that is 0 to 4. So in this particular case I am going beyond the boundary, and here so before this particular 0, then I am trying to access a of minus 1, a of minus 2 and so on. So this is not allowed. If you try to access the array element something like this, so it may corrupt the data. There is one possible consequence that we will see in programming. So if you are going outside the boundary, and many in some certain situations we may get the fault as segmentation fault. When you programming, so whenever we try to access an element outside the array boundary, outside its so memory limits, if you try to access the data, then you may get the error as a segmentation fault. And also it could expose a system to a security hole. The security hole in the sense, so certain information if you try to access there, so the data will be insecure, and we should not access any particular array element outside its boundary. So always we should access the array elements within the limits. So the index starts from 0 and it goes up to n minus 1 if n is the size of the array. Then, so let us see some of the very few simple programs on the arrays. So if you look at this particular program here, so I have declared an A as an array of 5 integer elements. If you look at this particular declaration here, so I am declaring here the A as an array of so 5 integer elements, and I have taken one more local variable called I. So here I am taking a loop instruction here, I is equal to 0, I less than 5, I plus plus. So here what I am trying to do is A of I is equal to I plus 100. So when I is equal to 0 here, it will enter into the loop, and here so A of 0 is equal to 0 plus 100 will be the consequence. So that is, so 0 plus 100 means it becomes 100 only. So A of 0 will get the value as 100. Similarly, so after this loop, body of the loop is executed, it will go for the incrementation, and I is incremented to so 1. So again here 1 less than 5 condition is true. So we can see that here when I is equal to 0, so A of 0 is calculated as so something like the 100, and when I is equal to 1, so what happens is 1 is less than 5, the condition is true here, A of 1 is equal to 1 plus 100. So here A of 1 we will be getting it as so 101. And similarly when I is equal to 2, the 2 is less than 5, again the condition is true, we will come to the body of the loop, A of 2 is equal to 2 plus 100. So as a consequence we will be having like A of 2 so equal to so 102. So and so on. When I is equal to 4, so 4 is less than 5, the condition is true, we will come to the loop here, A of 4 is equal to so 4 plus 100, so it becomes 104. Again when I is incremented, I becomes 5, 5 is no longer less than 5, it will be coming out of the loop. When it comes out of the loop, so we go for the next for loop, wherein we are trying to print the array elements. So I is equal to 0 again here, so I value was 4 in the previous loop ending, so now the I value has become 0, again we are trying to initialize that value as a 0. Again 0 is less than 5, element percentage d equal to percentage d. This particular so percentage d correspond to the index, and this particular value correspond to the array element value what we are trying to print over there. So it will print when I is equal to 0, it will print A of 0 as 100, when I is equal to 1, it will print the A of 1 value as 101, when I is equal to 2, it will print the value of A of 2 as 102, and so on, so up to I is equal to 4. So when 4 is less than 5, so it condition is true, again it comes to the loop and it will print the statement there, element per 4 is equal to percentage d, A of 4 will be printed over there. So now if you look at the output of this particular code, so this is the possible output what we will be getting here. So that's what element of 0 is equal to 100, element of 1 is equal to 101, element of 2 is equal to 102, element of 3 is equal to 103, and element of 4 is equal to 104. So using the looping construct, you are trying to initialize the elements of the array, but here we are not initializing the array elements at the time of declaration. So once the declaration is over, after that in the course of execution of the program, you are trying to initialize the values of each of the elements of the array here. So now, so if you consider this particular program here, so it is similar to the previous program. So but here, so I am declaring an array, and here instead of adding I to the I plus 100, here the statement is like A of I plus 100. So this is the statement, and we can see here like here I have declared the array of 5 integer elements, and here I am not initializing any value for this. So with respect to this statement, when I is equal to 0, so what we will be getting is A of 0 equal to A of 0 plus 0, because I value is 0 over there. So we will be getting, so A of I is equal to A of I plus I, mean it becomes when I is 0, A of 0 is equal to A of 0 plus 0. So but what is the value of A of 0? So, here since I am not initializing any data over there, so we have seen that if this declaration is similar to the normal local variable declaration. So, by default they will be having some junk value or some we say like garbage value. So, here we cannot have any predicted value in this particular memory location. With respect to this 5 into 2, each integer will take 2 bytes of memory area. I am declaring here the 5 integer type. So, 5 into 2 is 10 bytes of memory will be allocated for the array A there, and when I try to access A of 0, some memory content will be there. So, that will not be irrelevant to our programming. So, here we call that particular data which is irrelevant to our program, so as the garbage value or the junk value. So, we cannot predict. So, what is the value of A of I here when I is equal to 0, A of 0, similarly when I is equal to 1, A of 1, A of 2, A of 3 up to A of 4. We will not be able to get the values of these particular things. So, here the what output we can expect is like, so we get the some junk values for each of these particular elements of the array. So, now if you see the output of this, element of 0 is something like 67,493, element of 1 is equal to 15,646, element of 2 is equal to 1033, element of 3 is equal to 98544, element of 4 is equal to 10499. So, this is some junk data, it is getting printed over there. When you execute this particular code, you may get some other different data. It is not the same data what I am projecting here. The reason is, so the based on the memory content, A of I will be getting added with the value of I. So, is that the different data will be printed over there. So, this is because the array elements are not initialized here. So, because of which, so this is the consequence. Now, if you look at this particular code, this is also similar to the previous code, but the thing is I am using the statement here A of 5 is equal to 0. When I use this A of 5 is equal to 0 here, so this is partially initialized. We have seen in the previous session that whenever the array elements are partially initialized, rest of the elements will by default will take the value as a 0 here. So, but here what happens is I am assigning with this A of 0 equals to 0. When I do A of 0 is equal to 0 here, remaining 4 elements are not being initialized here. So, they take the default value as a 0. So, obviously, A of 0 is 0 here, A of 1 is 0, A of 2 is 0, A of 3 is 0, A of 4 is also 0 there. So, when I come to the loop here, so I is equal to 0, I less than 5, I plus plus, A of I is equal to A of I plus 1. So, since A of 0, A of 1, A of 2, A of 3, A of 4 values are, so zeros here. So, here only thing is A of 0 will get A of 0 plus I means, so A of 0 will get the value as a 0. When I is equal to 1, A of 1 is equal to A of 1 plus 1. So, A of 1 will get the value as A of 1 plus 1 means A of 1 value is 0 there. So, 0 plus 1. So, A of 1 will get the value as 1. Similarly, A of 2 will get the value as 2 and so on. So, here you can notice that here I am not using any block opening and closing flower braces. So, that is, so when I have only one statement within a block, so I can omit writing the opening and closing flower braces. But for your reference, I am writing here the opening and closing flower braces. It is here also, it is not mandated that I should use the opening flower brace and the closing flower, because in the body of this particular loop I have only one printing statement here, right. So, in this body of this particular first loop, what I am using here, I have only one statement to be executed there, A of I is equal to A of I plus 1. So, now what we can expect here, the output as A of 0 value will be 0, A of 1 value will be 1, A of 2 value will be 2 and so on up to A of 4 value being the 4. So, if you see the output of this particular program, so here we get the output as element of 0 is equal to 0, element of 1 is equal to 1, element of 2 is 2, element of 3 is 3 and element of 4 is 4. Now, so if you want to read the values of an array element from the keyboard, see in the previous cases, here we can see that we are explicitly initializing this particular array elements through programming. Either we are reading the data, so we are initializing the array elements at the time of declaration, or in the programming. So, this is initializing the array elements. So, this is initializing the array elements at the time of so declaration, and here I am updating the values of elements of an array. When I value is 0, I am updating A of 0. When I value is 1, I am updating A of 1. When I value is 2, I am updating A of 2. Similarly, when I is equal to 4, I will be updating A of 4. This is explicitly, so I am updating the each element of an array, and here at the time of declaration of an array, I am initializing the array element. Now, so if you want to read the elements of an array through the keyboard, that is from the console input, if you want to read in, the elements of an array, then this will be similar to the normal variable how we are going to access using the keyboard. Say for example here, so I have declared int x, x is a variable of type integer and y is a variable of type of float, z is a variable of type a character. If I want to read the data for x, y, z respectively through the keyboard, I will be using the scanf function, and here I use the format specifier as a %d. The %d correspond to the reading of the integer element, the format specifier %f correspond to the reading of the floating point element, and for %c correspond to the format specifier for the character. So here, so when I do %d %x, with this particular ampersand, I will be providing the address of x. X is being the variable of type integer, so I will be reading the data for the x, which is of type integer, so I will be using %d there. Similarly, if I want to read the value of y, so y being the floating point value, I am using %f here, and here I will provide the address of y, %y, and I will get the value of y. Similarly, if I want to read the z value, z being the character data type, I will be using the format specifier as %c, and here I specify the address of z. So I specify %z there, I will be reading the data for the character there. In the same manner, we can even use the array index to read the data of the array elements from the keyboard. Here you can notice that a of 5, this says that a is an array of 5 integer elements. So here we have the elements from a of 0 to a of 4. So if you want to read each of these particular element, my statement will be like scanf %d, then ampersand a of 0. This ampersand a of 0 specify that address of the first element. The index starts from the 0, so it is 0th element is the first element. So here ampersand of a of 0, and for the second element I can use like scanf %d ampersand a of 1. Similarly, for the third element I can use like ampersand a of 2, and for the fourth element I can use like ampersand a of 3, and for the last element I can use like scanf ampersand a of 4. So here we can notice that array element can be accessed in a similar way how we are going to use with the normal variable. Here also we use %d, and you can note that if this is of type of float, then a will be an array of floating point integers. When it is a floating point type, so here the format specifiers we are supposed to change this %d to %f. Similarly, if it is of type character, then a will be an array of 5 character elements, so we must change the format specifier, so %d to %c. Remaining all the things will be similar to the way how we handle with the normal variables. Now we will see a simple program, so wherein we access the array elements. So through the keyboard, we read the data for the array elements through the keyboard. Now, so look at this particular program. So I am declaring so a as an array of 5 integer elements. So a is an array of 5 integer elements. So I am displaying a message here, enter 5 elements. So we have seen that in the previous slide. So each of the element can be accessed like a normal variable. This particular %d correspond to the a of 0, the first element of the array. The second %d correspond to the second one, ampersand a of 1. You have to notice the syntax here. So within the double quote I specify what all the elements of an array I want to read. So all are of similar data here, right? So all the 5 integer all the elements of a, that is a of 0, a of 1 up to a of 4, all are of type integer. So here the format specifier is %d, 5 %d's I have used here, 1 2 3 4 5, and here each of this particular element address I am going to provide there. So here the syntax is like within the double quotes I should specify the format specifier, format string, then after that separating the comma I have to specify each of the elements address here. First I specify the address of a of 0, next I specify the address of a of 1, next I specify the address of a of 2, and next I specify the address of a of 3, and next I specify the address of a of 4. So here, so all the 5 elements, so addresses I am referring there, and whatever the data I enter, that all will be stored in the address mentioned as the parameter there. Now similarly, now I am trying to print all the 5 elements back on the screen. So here also all the 5 elements being the integer type, I will be using here the 5 %d here, because each of the element are of type integer. So here, so again I will print here a of 0 the first element, a of 1 the second element, up to a of 4 the fourth element. Here also first %d correspond to the a of 0 value, the second %d correspond to the a of 1 value, the third %d correspond to the a of 2 value, and similarly the last %d, which is the fifth element, correspond to the a of 4 value. Fine. So this is the way I am going to read. So you can notice that in the previous here I use 5 different scanf statements here, right, but it is not mandatory that I should use the 5 different scanf always to read the elements of an array in one scanf itself. So I can write the complete program here. Instead of using the 5 different scanf statement, within one scanf statement I can specify all the percent format string and I can specify the address of each of the elements. So you clearly note that here if it is like a of 500, then I may need to specify here the 500 percentage D's. So now the possible outcome of this particular program is like, if I am entering the value of a of 0, a of 1, a of 2, a of 3, a of 4 as 1, 2, 32, 56 and 8, then the possible outcome of this particular program will be like the same elements will be get displayed, because a of 0 value is 1, a of 1 value is 2, a of 2 value is 32, a of 3 value is 56 and finally a of 4 value is 8 here. So now if I have 500 elements, what is the way of programming here is like, I must use 500 percentage D's and I have to specify the address of each of the 500 elements, that is from a of 0 to ampersand of a of 0 to ampersand of a of 499. So again, so here this is not the right way of programming. So this way of reading and printing an array is not easy and not recommended. So if array size is large. For the smaller size array, if it is an array of 5 elements or 3 elements or 6 elements, something like that, the things can go smoothly. So wherein I can use the 5 percentage D's or 6 percentage D's to read the element and specify their addresses. But if the size of an array is too large, something like if it is an array of 50 elements, 100 elements, 500 elements and so on, then using the scanf statement in this format could be a difficult task. So here we must make use of the advantage of an arrays, right? So we will see in the next program. So how arrays can be helpful in writing the programs using the looping constructor. Now here you can see like int a of 5. So again here, so a is an array of 5 integer elements. I have taken one local variable I here, then enter 5 elements. So here I am asking for the 5 different integer elements there. So now you can notice this particular looping construct, we were using the 5 different percentage D, wherein I was reading taking the address of each of the elements a of 0, a of 1, a of 2 up to a of 4, and I was giving the address there and I was reading the values for each of the 5 elements there. But having this particular looping construct here, when I is equal to 0, I will come to this particular scanf statement. I have only one statement within the body of the loop, so I will not be using here the opening and closing flower base for the block. Now when I is equal to 0, 0 is less than 5 condition is true, I will come to this particular block. So here scanf percentage D ampersand a of 0. So I will be taking the address of a of 0 and whatever the data I will enter here, so that will be stored in the a of 0. Similarly, when I is equal to 1, so 1 is less than 5 condition is true, again I will come to this particular body of the loop, scanf percentage D ampersand a of 1 will be the statement there and it will read the second value. Similarly, I is incremented further, so 2 is less than 5 condition is true, it will come to the loop, again it will read scanf percentage D ampersand a of 3. So it is, since I is getting changed in every iteration of the loop here, so meanwhile, so I will be reading all the 5 elements of the array. So here no need of having the 5 or 6 different percentage D's here. So now if I change the size of the array as 500, then the same looping construct will satisfy the requirement. Only thing is here I should change the condition as I less than 500 here. So that is sufficient. So with this I will be reading all the 500 elements. Even for the displaying of the 5 elements also I will be using the same looping construct. When I is equal to 0 there, so I will be using, so print of percentage D a of 5. When I is equal to 0, I will print a of 0 value. When I is equal to 1, I will print a of 1 value. When I is equal to 2, I will be printing a of 2 value and so on. So I will be reading all the elements in this particular looping construct, and here in this particular looping construct I will be displaying all the elements of an array back to the screen. So now the possible output is here, if I am giving the same input which I was given in the previous program, so here you can see like I have used a different percentage D for each of the element. Individually I have read the element there, so in a single scanf statement without using the looping construct. Here also I am printing the array elements back on the screen without using the looping construct. So I have used 5 percentage D's and also I have used so 5 percentage even in the scanf statement. But if I come to the looping construct here, I used only one scanf statement with having only one format specifier percentage D. But because of the looping construct, a of I am using there ampersand of a of I, that I when it is 0 I will be reading the the a of 0 value when I is 1, I will be reading a of 1 value, when I is 2, I will be reading a of 2 value. So, things has become very simpler. So, when I am using the looping construct along with the array construct. So, it is recommended that whenever I am using the arrays, I must use that along with the looping construct, because the things will be very simpler. If I am using the normal way without using the looping construct, still I can program. Programs will be right. There is nothing wrong with the program which I so given in the previous case. Even this program is also correct, but only thing is so much things to be typed over there. So, many times we have to use %d and all, but if you use the looping construct, then programming could be very easier. So, here the possible outcome of this particular output of this program is like I am entering the values of 5 elements as 1, 2, 32, 56 and 8, and the 5 elements will be displayed as 1, 2, 32, 56 and the same elements will be get displayed as per the statement there. Next, so next we will see, so one of the problem, so wherein in an array of integer elements we are supposed to compute the maximum element. So, here I have taken the array of elements as minus 15, minus 25, 12, 25 and minus 55. So, A is an array of 5 integer elements there. The index starts from 0. So, this is the index, so which is starting from 0 and it goes up to 4, and name of this array is so 5 here, right. So, A of 0 value is minus 15, A of 1 value is minus 25, A of 2 value is 12, A of 3 value is 25 and finally, A of 4 value is minus 55. So, now, so here, so initially this arrow is pointing to the 0th index. So, I call this index I is equal to 0 and element is A of 0 value, A of I is equal to A of 0 is equal to minus 15. When I am computing this particular the maximum element in an array of an integer elements, I assume that the first element itself is the maximum value. When I assume this as a maximum value, then I should compare with the rest of the elements, so to conclude which is the maximum element in an array. So, this is the logic. So, what normally every human being may apply in computing the maximum element in an array of integer elements. Now, here if you look at the 5 elements here, we can directly say that 25 is the maximum element, but what is the logic I have applied in my brain, so to compute the maximum element in an array of 5 integer elements. So, here what we have seen is, so within a short span of time, so here minus 15 is lesser value, again minus 25 is lesser value compared to 12, 12 is so lesser value compared to 25 and minus 15 is lesser, 55 is lesser value compared to 25. This we have computed and finally we declare that 25 is the maximum value. This is algorithm what we have applied in our brains. Only thing is here we try to convert that logic whatever we have applied into the programming statements here. So, for that what we do is when I is equal to 0, with the element A of 0 that is being minus 15, we assume it as the maximum value. Now, minus 15 we compare with the next element. See now, so here we assumption is like maximum is equal to minus 15, because we have said read like when I is equal to 0, the first element of the array A of 0 that is being minus 15. Now, when I is equal to 1, so what we will do is we will take the next element of the array, that is minus 25. Earlier we have assumed like the max is equal to minus 15 here. Now, when I take the element minus 25 here, so I will compare this max with the minus 25. Is our assumption is still correct or not? We are supposed to compare and conclude. Now, here minus 25 is the element which is currently, so it is pointing to the index is, so A of I is minus 25, minus 25 is lesser than the max value which is assumed. So, max value is assumed as minus 15, which was the first element there, 0th element I mean. So, now since minus 25 is lesser than the max, so I can conclude that our assumption is correct, and that comparing to minus 15 and minus 25, minus 15 is the maximum value. Now, if I go for the next iteration, then when I is equal to 2, so I will be pointing to the element A of 2. A of 2 means the value is 12. So, our assumed maximum value is minus 15. Again, I am supposed to do the comparison in programming. So, the current value is 12 here. Is it maximum greater than the assumed max value? We will see. But 12 is greater than the max value, because 12 is greater than minus 15. Our assumption is like max value is minus 15 here, and this 12 is greater than this particular assumed max value. So, we conclude that assumption is wrong. So, when the assumption is wrong, we update the max value to the current value whichever we are getting as the maximum element. So, after this we will be updating that as max value is equal to 12. So, now we go for the next element. So, that is the a of 3. When I is equal to 3, we try to access the next element of the array. So, a of I is equal to a of 3 is equal to 25. Now, again we compare this 25 with the assumed max value. So, what is the currently the max value so far what we have scanned? So, here among 50 minus 15 minus 25 and 12, the 12 is the maximum value, right. Now, again we are supposed to compare this with the current element which is under scan. So, now my 25, the 25 is greater than the assumed max value, because 25 is greater than 12. Again our assumption is wrong here. Whenever our assumption is wrong, we have to update the max value. So, now assumed max value is 12. Now, I will update this to 25. Now, the max value will be 25. In the next case, when I becomes 4, so element under scan will be like a of I is equal to a of 4 is equal to minus 55. Again I do the comparison here. Minus 55, is it greater than the max? Minus 55 is less than the max. Our assumption is correct that 25 is the maximum element. We will not be knowing that, we do not have whether we have in further the elements in the array or not. But when we see, so the index becomes I is equal to 5, but it is an array of 5 integer elements. The index will go from 0 to n minus 1. When n is equal to 5 here, in an array of 5 integer elements, index will go from 0 to 4. But here you can notice that index value is I is equal to 5. So, no more elements exist. When we come to this particular situation, so what is the maximum value currently we are holding? It is 25. So, now we can conclude that the maximum element of an array is the 25, right. So, now this is the algorithm, so which we can use for writing the program here. So, algorithm is like, so print element some max element. So, here, so we begin with an algorithm. A is an array of n integer elements, and then so max is equal to a of, so this is the assumption what we are making. So, initially we assumed like, so maximum value is equal to the 0th element. Then afterwards we compare the elements from 1 to n minus 1. If you look back to the previous slides, we can see like we have assumed like the initially the max value as a of 0th value, that is minus 15, and then we have compared the max value with the rest of the elements. As and when the assumptions went wrong, we have updated the max value. So, the same logic we have to write in the algorithms, and then that algorithm has to be converted into the programming statement. So, here I assume that max is equal to a of 0. Assume beginning element is a maximum element. Then the remaining elements will be like, since I have assumed a of 0 as the maximum element, the remaining elements will start from 1. So, I is equal to 1 to n minus 1 do. What is to be done in this particular looping construct here? So, here if a of I is greater than the max, so means the current value when I is equal to 1, if the a of 1 is greater than the max, then update the max value. If it is not greater, I no need to confirm. So, any updation there, I have to go for the next element. Fine. So, a of I is greater than max, then I am updating it, otherwise, so I am going for the next element of the list. So, here at the end of the loop, when all the elements get exhausted, I will be coming out of the loop, and when I come out of the loop, max will be having the maximum element of an array. Now, if you see here, when minus 15, so is the assumed value, here when a of 0 was the minus 15, I assumed that max value is minus 15, and when I compared in the next case with the minus 25 is less than the max, so our assumption is correct. So, here since our assumption is correct, I cannot conclude that minus 15 itself will be the largest value in the given list of elements, unless and until I compare with all the elements of the array, I cannot conclude which is the maximum element, right. So, now, so in this particular case, so 12 is greater than the max, fine. The assumed max value is minus 15, that was right in these two situations. So, when minus 15 and minus 25 was taken into consideration, minus 15 is the maximum value. But when I have seen that 12 taken into consideration, then 12 is more than this particular assumed max value, that is minus 15. So, we change that max value to 12, but when we change the max value to 12, I cannot conclude here itself that 12 is the largest value. So, of course, after the rest of the elements in the array may be the lesser value or maybe the greater value. So, our job is to compare the max element with the rest of the elements in the array, fine. So, with all the elements of an array, I should do the comparison only at the end of the array. So, I can conclude that the maximum element is, so far what we will be having the program variable max. So, here the max has got 25. So, the 25 is the maximum element. So, how we can conclude there. So, similarly, this is the algorithm here. And now, so if you write the program associated with this, the first statement here is max is equal to a of 0, then we have the looping construct, and then we have a condition there that this to be simulated. So this is the algorithm is like a, it's not like a really like a program, fine. So this is here we have English like instructions, so this has to be converted into a programming language instruction. So here, so we will be reading, if you look at this particular code here, so a of 50. So I am assuming here, so a is an array of 50 integer elements. So one special feature here in this program, what you can observe here is like we are not using array of 5 integer elements, whereas I am allowing the user to specify number of elements he wants to read. So here I have taken one more variable called n and one more variable called max to hold the maximum element of an array, and one loop iterator I. So altogether here I will be using so 4 different. So one is an array, the 3 other variables I will be declaring here. Now enter the number of elements. So this is most important here. I should ask for the user to enter the number of elements of an array. The user wants to enter some 10 elements, so I should have the space here for 10 elements. If the user enters 50 elements, then I must have the space there. So we have to mention here like, so the value of n can be greater than or equal to 0, but less than or equal to 49. It cannot be equal to 0 also, but a of 0 means, so when there are no elements, no need of finding the maximum element there. So it is logically states that the n value should be greater than 0 here, and it has to be less than or equal to 49. I cannot have the n value as 51 or 52, something like that. I can have a maximum 50 elements there. So I should make sure that the value whatever I read here, number of elements, it has to be lesser than the 50 there. So with this I will be reading the number of elements whatever the user enters. Next, after that I should read all the elements, the n elements of an array. So using the for loop construct. So here enter percentage d elements of an array. So here percentage d will be replaced with the n. If I have entered 5 elements there, then enter 5 elements of an array could be the statement. And if I have entered n value as 10, if I wish to enter 10 elements of an array, then the enter 10 elements of array could be the printf statement outcome. Then for I is equal to 0, I less than n, I plus plus, I will be reading all the 10 elements of an array here. So span of percentage d ampersand a of 5. When I value is 0, I will be reading the 0th element. When I value is 1, I will be reading the first element. When I value is 2, I will be reading a of 2, and so on up to n minus 1, because a of n is the size of the means number of elements I will be entering. The index starts from 0, so I should go only up to n minus 1. So after reading all the elements of the array, then I will come for the logic of implementing finding the maximum element in an array. When initially I assume here that max is equal to a of 0, 0th element is the maximum element. Then I should compare from the first element till n minus 1. So I less than n, so I plus plus. What I will be doing is, if a of I is the greater than the max, if the a of I value currently, if it is greater than the assumed max value, then I will be changing the max value to a of I. If it is not greater, then I do not alter the content of the max variable. I just run the loop with the next iteration, right? So at the end of the loop, when the I value is less than n, the condition fails, I will be coming out of the loop. When I comes out of the loop here, the max will be having the maximum element of an array. So I will be printing that print of maximum element of an array equal to percentage d comma max. So I will be printing the maximum element over there. Now similarly, so if you can compute the minimum element search problem. So here we will be trying, in a given array of n elements, we are trying to find the minimum element in the array. Now say here also the logic remains the same. In the previous case I have computed the maximum element, but here it will be minimum element. So the logic remains the same here. First we assume that the 0th element itself is the minimum element. I compare with the next element. Whenever the minimum element we encounter, we change our assumption to the new minimum element, and we continue until the list get exhausted or the array get exhausted. So here, so I am supposed to do the 4 different comparisons to confirm that which is the minimum element in the array. I cannot conclude without comparing with leaving any one of the element of the array. I should compare with all the elements to confirm the actual minimum element of the array. Now when I is equal to 0 here, so the a of 0, that is minus 15, so will be assumed as the minimum value. So I assume that min is equal to minus 15. So is the assumption min is equal to a of 0 is equal to minus 15. Now, when I is equal to 1, so I will be looking into the second element of the array. So, that is a of 1, it is being minus 25. So, here, so I will compare the minus 25, is it still lesser than the assumed minimum value? Yes, it is true that minus 25 is lesser than the minus 15 value. So, I should change my assumption. Assumption is going wrong here. I should change the assumption. When I change the assumption, the minimum value should be updated as a minus 25. So, we can see that here minus 15 has changed to minus 25, wherein we can conclude that the assumption is wrong here. So, we have changed the value to minus 25. So, in the next iteration, we will go for the next element. So, next element is I is equal to 2, means it is the a of 2 being the element value 12. So, now the 12 is greater than the minimum value which is assumed. The minimum value assumed here is minus 25, and the current value under scan is 12, and 12 is greater than the minimum value. So, I cannot update the minimum value there, because the assumption is correct that the minimum value is minus 25 among minus 15, minus 25 and the current element to 12. Now, we should go for the next iteration. In the next iteration, we will go for the next element of the array, that is 25. So, when it is 25 there, we will see that 25 is again greater than the minimum element. So, the assumed minimum value is correct. So, assumption is correct here. So, no need to update the minimum value. So, when you go for the next iteration, so when I is equal to 4, we can see that a of 4 being minus 55 is less than the assumed minimum value. When it is lesser than the assumed minimum value, we have to change our assumption. Our assumption is wrong. So, I should update the minimum value. When I update the minimum value, so here we will be getting as minimum value is equal to minus 155. Now, when I go for the next iteration, so I is equal to 5. So, this a being an array of 5 integer elements, I do not have the 6th element there. So, when in index I is equal to 5, no more elements exist. So, what we can conclude like the minimum element of an array is equal to minus 55. So, now the code for this particular algorithm for this particular the problem solving is like, algorithm is find min element a comma n. So, when I find the minimum element in an array of n integer elements. So, here I assume that the algorithm begins here, I assume min equal to a of 0. I am assuming the 0th element itself is the minimum element. Then I is equal to 1 to n minus 1. Here we have to note that, so 1 to n minus 1 I will compare, so the assumed minimum element with the rest of the elements, and whenever the condition satisfies that the current element is lesser than the assumed minimum element, I will change the minimum element. Fine. So, here I is equal to 1 means a of 1 is less than the minimum element. So, will compare. So, if it is true, we will change it, otherwise we go to the next iteration of the loop. So, here the loop run from 1 to n minus 1. So, once I come out of the loop here, the min value will be having the minimum element of an array here. So, that will be printed over there. This is an algorithm or the pseudo code, and now we are supposed to convert this or transform this particular pseudo code into the programming statements as per the C language. Now, here it is similar to the maximum element finding problem. So, here, so first I will declare the a of 50, an array of 50 integer elements. N is another variable I am declaring a number of elements of an array, min. So, I am declaring a variable to hold the minimum element of an array, and I is the loop iterator. So, these are the variables which I will be declaring for my programming. So, here enter the number of elements is a printing message there. Then I will read the number of elements of an array, and after that I will be reading. So, through this particular looping construct all the n elements of an array. So, here you can notice that I is equal to 0, I less than n, I plus plus, scan of percentage d ampersand a of I. So, when I is equal to 0, you read 0th element. When I is equal to 1, you read a of 1. When I is equal to 2, you read a of 2 up to I being n minus 1, you will be reading the value of ampersand of a of n minus 1. When I is equal to n is no longer less than n, you will be coming out of the loop. So, by then you have read all the n elements of an array. So, as per the logic of this particular program, so you have to assume that min value is equal to a of 0. 0th element is the minimum value there. So, then from I is equal to 1 to n, so n minus 1, what is supposed to do is you have to take the individual element and you have to compare with the assumed minimum value, and if there is a change you have to update. So, otherwise, so you have to retain that particular minimum element value. When a of 1 is lesser than the min, I will update this, otherwise I will go for the next iteration of the loop, and no need of writing else here. if the first element a of 1 is lesser than the min, so I can conclude min is equal to a of I, else means I cannot write that the min value itself is the minimum element of an array, because until and unless I compare with all the elements of the array, I cannot conclude there, so which is the minimum element. Fine. So once I comes out of the loop, whatever the min value getting updated there, so that will be the minimum element of an array. So finally we print after coming out of the loop the minimum element of an array equal to percentage d under min. So this is how we can program to find the maximum and minimum element of an array. So using this, so looping constructs and the arrays. Now, so now if the question is like program to find minimum and maximum element in an array. So if we want to compute the both the minimum element and the maximum element of an array. So here so in the previous programs we have seen how to compute the maximum element of an array, and also we have seen how to compute the minimum element of an array. The logic of both I should include in my program to find the maximum as well as minimum element in an array. So here my programming will be like, so int, I write the main function, and the program variables that are required here is int, the declaration of the array here. So a of 50. So whenever I am declaring the array, see that the data type, name of the array, then within the square bracket I should specify the number of elements. Then I require one more variable, number of elements, and then I may take two variables there, max, and also I need to take one more variable called min and a loop iterator I. Fine. So then I supposed to request for the number of elements of an array. So that is enter value of n. In other words, it is, so enter the number of elements of an array. So then I supposed to read the value of n, percentage d ampersand n. Then after that we supposed to read all the n elements of an array. So for that I supposed to use the looping construct. So before that I can have a display message, so requesting for enter the n elements of an array. So here wherever possible try to format the output in a neat fashion. So enter percentage d elements of an array. Then after that I should take a loop for I is equal to 0, I less than n, I plus plus. Since I need only one scanf statement, so I no need of any further statements in the looping construct. So within the body of the loop I will be using, without using any opening and closing flower base, I will be writing this particular statement. So here when I is equal to 0, I will be reading a of 0, when I is equal to 1, I will be reading a of 1, and so on. When I is equal to n minus 1, I will be reading a of n minus 1. So all the n elements of an array I will be reading with this. Now after this I supposed to compute the maximum element and the minimum element. As per the logic, I should assume that the max is equal to min is equal to a of 0. This is most important. Fine. So our assumption is like the 0th element is the maximum element and also the 0th element is the minimum element. Now I should compare this element, the max and min, assumed max and min value, with rest of the elements of an array. For rest of the elements of an array means, so for I is equal to 1 and I less than n, I plus plus. So here in this particular loop I need to compare if a of I, that is the next element, is greater than the assumed max value, then I should change the max value as a of I. And here I cannot write else, fine, because min is a different concept and max is a different concept. Min is the minimum element of an array, max is the maximum element of an array. If a of I is greater than max, I can assume like max is equal to a of I, but else means I cannot take that will be the min value. We have to compare the assumed min value with the current element, that is when I is equal to 1, the a of 1 value, only then I should confirm based on the condition whether that element will be the minimum value or not. So the statement will be like, again I should check the condition, if a of I is lesser than the min value, then I should assume like min is equal to a of I. fine. So, this particular loop I should run. So, n minus 1 times because I am starting from 1 here. So, n minus 1 times when I run this. So, finally, at the end of this loop I will be having the max as the maximum element of an array and the min as the minimum element of the array. So, in the next printf statements I can mention. So, there what is the maximum value and the minimum value, and I can write this printf statement there. And after displaying that, so you can close this main function. This could be the code. So, wherein we will be computing the max value as well as the min value. The code again I will display here. So, here you can see that. So, we have declared here the array of 50 integer elements. The n is the number of elements you may ask for the user to enter. Min and max 2 variables you have taken there, and the loop iterator I. Next, so enter percentage d elements of an array. You are reading n elements of an array there. Then I is equal to 0, I less than I plus plus scan of percentage d ampersand a of I. Fine. You will be reading all the n elements of an array. Then you assume that min is equal to max is equal to a of 0 there. Then for I is equal to 1 to n minus 1, you have to check for all the conditions there. If a of I is lesser than the min value, min is equal to a of I. Similarly, if a of I is greater than the max value, then max is equal to a of I. So, until all the elements of the array are being compared, so you cannot conclude which is the minimum and which is the maximum value. Fine. At the end of this loop, when it comes out of the loop here, so the min value will be stored in the min variable and the max value will be stored in the max variable. So, you are supposed to display like min element is equal to percentage d and max element is equal to percentage d. So, you will be printing the minimum value as well as the maximum value. So, next is the searching problem. Fine. So, this is the we have learned how to write the program using an array to find the minimum element and the maximum element of an array, and the next is the concept of searching problem. So, what exactly the searching problem is? You will be given the list of elements. In that elements you will be also given the key element. You are supposed to search whether the key element present in the list or not. It is as same as when you are using the mobile phone, you may be having so many different contacts. If you are looking for a particular contact in the list of contacts that you have, there is nothing but the searching, and here different algorithms will be used to perform that particular operation. So, searching for a particular key element in the list of elements. So, here we have two types of results. Search can be a successful result or it can be an unsuccessful result. That is, if the key element which you are in searching, if it is present in the list, we call it as a successful search, and the key element what you are searching is not present in the list, we can call that as a unsuccessful search. So, here we will be learning the two different methods of performing the searching. One is the linear search, which is also called as the sequential search. Sequentially, one by one element you search and you conclude whether the element is present in a list or not. The other one is the binary search. The binary search will divide the complete list of elements into two halves and it performs the searching. So, we will see in the next session. So, what exactly? So, we will perform the operations of linear search and the binary search, and we will see how to program the logic of linear search as well as a binary search. So, I will end this session here and I will continue in the next session. Thank you.